Okay, this is geometry, section 5.2, medians and altitudes of triangle. Now, we discussed perpendicular bisectors, didn't we? Remember that a perpendicular bisector does several things in a triangle. Well, first of all, a perpendicular bisector not only bisects the other side, but it is perpendicular to it. Remember that. Remember I showed you that you could bisect something and not be perpendicular to it, okay? We also talked about how distance was the perpendicular distance, right? From a point to a line. All right. And what did we call the perpendicular bisectors of, what did we call when the perpendicular bisectors intersected in a triangle? What concurrent point is that called? You need to know this.
Concurrency.
No, well, it's a point of concurrency, right? But what is the name? We give it a specific name when it was the perpendicular bisector. It was what? No.
Incenter.
No. Circumcenter. Okay, you need to know that. Whoops, at the end. Circumcenter, right? And the circumcenter can be on the inside, the outside, or on the circle, depending on what happens, correct? Now you're going to have to know the difference between all of these. That's why I keep stressing it over and over and over. It's not for my benefit, it's for your benefit, okay? So it's called the circumcenter. And that circumcenter is equal distance from the 3 points of the triangle, right? Okay? And then we talked about the angle bisectors, did we not?
Yep.
And the angle bisectors bisected all three angles, and they met in a point of concurrency called the what?
Incenter.
It's called the incenter. And the incenter was always in the triangle, wasn't it? Never on the outside of the triangle, never on the triangle. It was on the inside of the triangle, right? The incenter is equal distance from the sides of the triangle. Okay? Now that's important because I'm going to draw these two to you. I'm just going to draw one. I'm going to call it AB. Here's a triangle, right? And if I do the perpendicular bisector, that has to be marked and that has to be marked, right? That's called, let's go ahead and right through this. So this is AB, right? And this is a perpendicular bisector. So A line segment AB is a perpendicular bisector, right? Everybody understand? Now if I throw another triangle up there, it doesn't matter how the triangle is gone, and I do this, and I mark this and this, this is marked, and this is AB, then line segment AB is a what? An angle bisector. Do you see the difference? Am I off this chart there? Okay? Okay. All right. Because today we're going to talk about this word. A median. A median is a line segment that joins. Now, can it be a line? No. Median is a line segment that joins a vertex of a triangle and the midpoint of the opposite side. A median is a line segment that joins the vertex of a triangle and the midpoint of the other side. So I'm gonna draw the triangle a little bit bigger this time. Okay. We good? Call this A and this B and this C. Okay. Here's the midpoint of the other side. I made that up. I just said that's a midpoint. That means that this side is congruent to this side. Do we all understand that? A median joins the vertex from the opposite of that side to that. Oops, that goes through there. All right? And we'll call this point K. I'm going to change that. Sorry, I'm going to change it to D. There's a reason for that. I'm not just making this stuff up. Let's call it D. Okay? Does everybody understand that? You see the difference between that and a perpendicular bisector? It almost looks like an angle bisector. How do you tell the difference? What's that? It's marked. Tell me, be specific on it's marked. Okay, here the angles are marked congruent and here the sides are marked congruent. Okay, we good? Do you understand that? Okay, so now the next one, I'm going to draw from this vertex to the midpoint. The midpoint looks about right there. Does that look like the midpoint to you? And we'll mark these. Why do I mark them with 3 marks instead of 2? They're not the same, okay? So I'm going to bring this straight down, and it's going to hit that midpoint, right? Are we good? We're going to call this point E. How many medians are there? How many will there be? 3, just like everything else. The last one is going to go right here, okay? And I'll mark this 1, and that's the midpoint. We're going to call that point F. Okay? And you'll notice that all 3 medians meet in a point called the centroid. So we have a circumcenter, we have an incenter, now we have a centroid. Okay? Now, if you'll read on page 365, if you'll read with me, we have the centroid theorem, which says the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So the centroid is 2/3 of the distance of the median. Now I'm going to explain that to you because we're going to have some math problems that deal with that. Okay? It's 2/3. All right? I'm going to explain that to you. So I'm going to come over here and I'm going to call this middle point Q. I'm going to put Q in there. Does everybody see Q? We good? Angel? All right. What it's saying is, I'm just going to use one example, but there are 3 examples. It says that line segment AQ, that means from here to here, is 2/3 the whole thing, which is line segment AD. Now, when I say 2/3 of AD, what operation is being expressed there? I'll ask again. When I say 2/3 of AD, what operation is being expressed? Multiplication. The word of means multiplication. Do you understand that? So AQ is 2/3. So this is AQ, right? It's 2/3 of the whole thing. You understand that? So that we have this other thing called QD, the rest of it. How big is it? It is 1/3 of AD. That's not in the theorem, but you can sure devise that, can't you? Yes, no, maybe? Okay? Any questions then? So far. So I want to explain something. How far is it from here to here? From B to Q. 2/3 of BE. So how far is it from EQ? 1/3 of BE. How far is it FQ? This is a trick question. FQ of FC. 1/3. I went backwards, didn't I? And it's from C to Q, it's 2/3. How do you know if it's 1/3 if the picture doesn't show it that way? Well, you go from the median to the centroid, it is 2/3. And from the midpoint to the centroid is 1/3. Okay? Does that make sense to you? All right? Okay. So I'm going to take out this one. And there's one advantage of doing it on the board is I can have it all pre-made. And we have this picture now. All right, I think it's labeled the same way. Is that correct? All right. So my question is BE is 9. That means the whole thing is 9 here, BE. I want to know how far it is, what is the distance of BQ and QE? Notice that since I'm labeling numbers for the distance, that I don't have the line segment marked. All right, without the line segment, in geometry notation is everything, right? Without the line segment, I'm talking about length. So how would I find BQ? How would I find BQ if I know BE is 9?
It's 2/3 of 9.
All right, it's 2/3 of 9, okay? So I'm going to go 2/3 of 9, and of means times. So I'm going to go 2/3 times 9, so BQ is 6. And you can put 9 over 1 and cross and cancel, right? We good? Connor, you good? So far. All right, so how far is QE? Figure out how far is QE. Anybody got an answer? How big is it? 3. There's 2 ways you can do it. You can do 1/3 times 9, right? Or since you found BQ, can't you just take 9 minus 6
Yeah.
and get 3? All right. Okay. All right, let's go over here. Now FC is 5. Find FQ and QC. FC, the whole thing is 5. How big is FQ? Your answer's not pretty, is it? How big is it?
1 2/3.
Or 5/3, which is 1 2/3. Very good, both of you. All right, so how big is QC?
Would be 3 1/3.
3 1/3 or 10/3. Whoops. I was supposed to say or 10/3. Either one. I will accept either one. As long as your fraction is simplified, I will accept it. Okay? All right, so I went down here and I went with a different look. You'll notice that on these 2 problems, I gave you the whole segment, right? And then I asked for the pieces parts. Okay? Now, what I'm going to do is I'm going to give you the pieces parts, and I want you to find the other piece part. Okay? So let's talk about this. PT is 2, right? Right here. PT is 2, right? I want you to find this piece. Okay? How do you do that? PT is 1/3 of the whole thing, right? I'm gonna tell you a little bit about how I do it. I find the whole thing first. I find the whole thing. So the whole thing is KT, right? And PT is 1/3 of it. 2 is 1/3 of what number? 6. How do you know that?
2
2 times 3 is 6, right? So the whole thing is, right? All right. So the whole thing is 6. So how far is KP? 4. Does that make sense to you? Okay. Not so easy on this one. Look at this one. RP is 3.5 and JP is 9. Find PL and PS. Well, let's start with this. RP is 3.5, right? Is that 1/3 or 2/3? It's 1/3 of the whole thing, right? All right, so the whole thing is RL, right? We need to change this to an improper fraction. How do you change 3.5 to an improper fraction? What is it?
It's 7 over.
It's 3.5, so it's 7 halves, right? And what do we multiply that by if it's 1/3 of the whole thing? We multiply by 3 to get the whole thing, right? So I multiply by 3 over 1. So that is 21 over 2. Does everybody understand that? Since it's 1/3, so 21. So the whole thing is 21 over 2, which I believe is 10.5, right? 10.5, right? I'm using a decimal because they started out as a decimal. Okay? That's the only reason I'm using it. Now that's the whole thing. They didn't ask for the whole thing. They asked for PL. What do I do?
Subtract
Subtract what?
7.5 and
How about 3.5? That was what this was, right? This was 3.5, and this is, the whole thing was 10.5, so if I subtract, PL is 7.5. Do you understand that? Kagan? Do you get that?
Yeah.
You want me to say it over? Tyra, you don't get it.
I do, yes,
You sure?
yes, I'm positive.
Okay. I'm glad you're positive about it. All right, so would you find PS for me? Whole different problem. PS.
Would it be just 7?
Oh, yes, it would be. Thank you. No wonder you were struggling with that. Would you just said, if I would have actually done the subtraction instead of just winged it, I would have known that. JP is 9, right?
Mm-hmm.
That's 9. Uh-oh. That's 2/3 of something, right? Can you just multiply by 3? No. So what do you do? You can take a third of 9.
Then add it to it.
Or did you do like 9 divided by 2? Yeah, 9 divided by 2 is what I was thinking.
Okay, so why would you take 9 divided by 2?
To find, because you have 2 over here, you need this one.
Okay, so if you take 9 divided by 2, you get 4.5, right? So the 4.5 is what?
Times 3? No, it's just 4.5.
It's just 4.5, isn't it?
Yeah, because they're from the whole thing.
That works pretty slick. Could you have done what Dylan did?
Yeah, it's just harder.
And yeah, but you could have done it, right? Yes. Okay. All right. Any questions about that? All right. Now, what if they wanted to know the whole thing on that? What would I have to do with the 4.5 and the 9? I would have had to add them, right? Okay. Any questions so far? All right. And those were what? Medians, and they met in what point of concurrency? What was it called? A centroid. Okay. So I think I got my camera off a little bit, so when you're watching this again, there might be some issues. Okay, so we've talked about perpendicular bisectors, we talked about angle bisectors. The next thing we're going to talk about is altitude. Guys, altitude is the toughest. Altitude is the toughest of the 3. The altitude of a triangle, okay, is a segment, line segment. That joins, nope, let's say it differently. Line segment from, let's put that, from a vertex to the line containing the opposite side. Now I'm going to explain this to you a minute because you're going to freak out. You're going to say, I do not understand it. The opposite side and is perpendicular to that line. Because you're going to have to identify all these on a test or a quiz. I will draw it. In fact, you're going to have to, I might draw one tomorrow. I might come in and put 4 of them on the board and say, is this a median? Is this an altitude? Is this a angle bisector? Is this a perpendicular bisector? Okay, so let's take a triangle. Okay, let's take a triangle. Let's stick with the ABC concept. Okay, and I'm going to choose a different color. actually, I'm gonna change ABC if you don't mind. I'm gonna make ABC, let's go with a little stranger look. Okay. Would you please change that for me? And I'm doing this for a reason, it's not to annoy you, although it will annoy you. Okay, I'm gonna talk about the altitude. So I'm gonna draw the altitude from C because it's the easiest to draw right now. And so what we're gonna do is we're gonna draw the altitude from C to this side, and so it's perpendicular, so it looks like this. Can you see that color all right? It's a little light. I'm trying to get a different color, but is this any darker?
Yeah.
And can you see a difference? Okay, you see it? All right. Does everybody see that? Okay. Now, now I want to draw from A to this right here, so that it's perpendicular to that side. You can see there's no way that I could draw a segment from A that is perpendicular to CB inside the triangle, right? So what I have to do is, and this is why I chose this one, is I have to extend this side out. And that's why we get is to the line containing the opposite side. Okay, so that line that I've extended out contains from C to B. Do you agree?
Mm-hmm.
Okay, now I can draw the altitude, which is straight down, and it looks like this. Okay? Any questions? The last one, I want to go from B to AC. But once again, anything inside the triangle is not going to be perpendicular, is it? So what I have to do is I have to extend this side out. Do you see that? Questions? And then I drop this straight down. Oops, I chose the wrong color again. Should be purple. You all see that? So two of the altitudes out of the three are outside the triangle. Do they intersect? No, they don't. However, what would happen if I kept going? Yes. Now I've drawn it kind of bad, so I'm going to redraw this. Do it like this. There. Okay. They intersect out here, don't they? Okay. Now I'm curious, if I drew a acute triangle, where would they all intersect? One would be here, right? One would be here, and one would be here. So where do they intersect? Inside. If I drew a right triangle, it would be on. Okay? Now, since they all three connect to a point, that is a point of concurrency also, right? And that point of concurrency is called an orthocenter. O-R-T-H-O-C-E-N-T-E-R, an orthocenter. An orthocenter. And an orthocenter is not, it doesn't have anything special. You know how one is like the center of the three vertices of a circle that connects the three vertices? That would be the circumcenter, right? And then the incenter is equal distance from the three sides, and then the centroid is 2/3 of the way. You see what I'm saying? This one, not. It's just where the altitudes meet. Okay? Do you get that? Dylan?
Yeah.
Okay. On page 369 is a little chart that shows you the four. It's so important that the author decided that he was going to put it in a chart. and I'll try to put it on there a little bit, and this is on that page. And he talked about the perpendicular bisectors being a circumcenter, showed them. He talked about the angle bisectors being an incenter, he showed them. The medians were the centroids, and he showed them, and the altitudes. So you need to know those. So tomorrow, it's quite possible, I'm just telling you, I know that some of you have, a lot of you have a game tonight, but still, you should need to know. I'm gonna come in and I'm gonna, number 1, you know, and I'm gonna draw a triangle, right? And I'm gonna do this. This is called A, and this is called B. Tell me what AB is. Which of the 4? It's what? It's a median. And then I might have a number 2 here, and I might do this. Draw a different triangle, and I might do this. And this would be called A, and this would be called B. What's AB? Alright, you see what I'm saying? So it might be a little 5-point quiz, and then I might say, what point, what do they call a point where medians meet? What do you call it? Centroid. And you got to know how to spell it, centroid. Okay, so that might happen tomorrow or the next day, okay? So be prepared for it. Do you understand what I'm talking about? So you have to understand. So we're going to have a worksheet that kind of works on it. And most of it's on centroids. Why is it on centroids? Because centroids are the 2/3 type thing, right? And that's the one. The worksheet looks like this. Okay? So the first part is they give you the pieces parts, and you are to find the other parts. You see them here? And same with this. This is all based on the centroid. I'm just going to have you, I'm going to have you try, let's try 13 and 15. So 1 through 12, 13 and 15. Okay, for tomorrow. Alrighty? Any questions on that? Alright.